I want to take a few minutes and look at Hurricane Sandy, its evolution and impacts from the point of view of a climate change scientist who spent the last 25 years examining the response of glaciers. In 1992, I went to a conference on natural hazards and climate change at MIT. We published a book of the same title. These are some of the chapters from that book. Mine was on changes in water supply due to glacier retreat. If I look back at this book, most of our forecasts in this book have come to pass, and we didn't necessarily have the timing right, but we generally did not overestimate the impacts. Now, if we look at global air and sea temperatures over the last decade, you can see they've been quite warm. And this has some long-term impacts. It takes a long time for air temperature to really warm sea surface temperature. If we look at this year, we have the highest air temperatures in the history of the United States through the first 9 months of the year, which of course is going to raise sea surface temperatures near our country. 476 all-time high temperature records, 10 low records. Now the key ingredients: sea surface temperatures need to be high enough for a hurricane. You have to have a low pressure center and limited upper level winds. Now notice along the track of Sandy, from where the storm formed in the Caribbean up along the coast, notice how high the sea surface temperatures are. That is a key for storm formation and storm growth. Here we see the path from its formation south of Jamaica up along the eastern seaboard of the United States. If we look at some snapshots through time, here's the hurricane just after it crossed Cuba. It's not a particularly startlingly large hurricane. As it moves up the eastern coast, it has an eye. It's a little lopsided. And it's, in terms of hurricane strength, it's not so high. But in terms of overall power, as measured by its pressure, we set an all-time barometric pressure record for the United States, and that's the best measure of the total energy of the storm. That was set at Atlantic City with Hurricane Sandy. Battery Park, the sea level rise has been continuing, largely due to warming of the water and glacier melt. You can look at this more globally in the Atlantic Ocean. You see the same thing, sea level going up. This is going to make every storm surge from any future storm a year from now, a decade from now, worse. One of the responses has been that, well, New Jersey's shores have eroded, and so New Jersey has spent literally billions of dollars renourishing and rebuilding their beaches. Now, their beaches don't have natural dunes, and so they don't absorb the storm surges and wave energy very well. Here's a picture of a beach being rebuilt, which is a constant scene in New Jersey from spring through fall every single year. Now with Hurricane Sandy, like any hurricane, some really big wave heights, 23 feet offshore of Revere, 33 feet south of Long Island, and that combined with your really high storm surge leaves you with a picture like this at Atlantic City at the lower of the high tides on that particular day, the noon high tide. That evening the high tide goes 1.5 foot higher. And we don't have a good footage of what that looked like out on the shoreline. But this was a record high tide for Atlantic City. We had a record high tide sea level at both Battery Park and Bridgeport. And this isn't all that surprising given that sea level is continuing to rise and warmer weather generates a stronger effect from creates a stronger storm. So we end up with a new destination for floodwaters like LaGuardia or subway stations. Again, neither one of these is a surprise. They're in the flood zone maps for this size of hurricane. We know that warming our temperatures raises the amount of energy a storm can tap into. We can see that the number of weather disasters has been increasing. This is due to climate change. It's not due to man's having more population because our other disasters like earthquakes haven't increased. 2011 was a record year for billion-dollar weather disasters in the United States. And we can just look, what will the record in 2012 be? In the Northeast, we had a record number of extreme climate events, record high temperatures, record snowfall, record rainfall. And this leads to some severe events in many occasions. And this is all counties in red experienced a $1 billion weather disaster in the United States. So most of us in the United States have experienced this. It has become quite clear to those of us living in the United States and other places in the world that extreme events are more common because our climate has changed, because it's warmed up, because of us. This is not a surprise. This is what we forecast 20 years ago. This is also what we anticipated would happen specifically with glaciers. In early October, I noticed a large calving event from the Thwaites Glacier in Antarctica. And it's what I will continue to document year after year, heading to the North Cascades of Washington and Alaska and Greenland. We did the lower rainbow. We really traversed down to the glacier, hit it about 5,200 feet. We're going to do the same thing today. Then we're going to ascend up to 6,000 feet, measuring the snow depths and the crevasses on the upper rainbow. And it's a very remote corner. It's a hard corner to see from anywhere. You certainly can't see it from any trail or any village or road or anything. So the only way to get to see the place we're going is to actually go there.